Case third, if right side portion is sin ax or cos ax, then the pi will be 1 over f d square sin ax. D square means we are only considering the function of d square, like d cube is equal to d square into d. So we are only talking regarding the this d square, or if d to the power 4, then we can say that d square dot d square. We are talking about this d square. So 1 over f d square is replaced by minus of a square if f of minus a square is not equal to 0. 1% if the f of minus a square is 0, then we have to multiply with x and differentiate the denominator term of d square with respect to d, and over here we have sin ax or cos ax. Then we have to again substitute d square is equal to minus a square and continue the process. Now considering the first example, y double dash plus 4y is equal to sin 3x. For left side portion, d square plus 4y is equal to this. The auxiliary equation will be m square plus 4 is equal to 0. That means m is equal to plus minus 2 iota. This is the complex root. Then for the complex root, by the rule of CF, we get C1 cos 2x plus C2 sin 2x. Now for the PI portion, 1 over FD square R, D square is replaced by minus of 9 because A is equal to 3, then D square is minus of 9, that is, remember this is minus 3 and square of 3, that will be minus 9, then the resultant will be minus 9 plus 4 is minus 5 sin 3x. So this is the PI. So the final solution for the differential equation is C1 cos 2x plus C2 sin 2x is the CF portion, plus the PI is minus 1 by 5 sin 3x. Now we are considering the second example. For this, y double dash plus 4y is equal to cos 2x. In previous question we are having a sine. Now over here we are having a cos 2x. If 1% it is sine 2x, the process and rule will be the same. D square plus 4d, the auxiliary equation will be m square plus 4, m is complex, then the CF will be C1 cos 2x plus C2 sin 2x. Substituting the value of d square value over here, because of this a is equal to 2, then minus of a square is equal to minus 4, so the denominator will be 0 if we substitute d square is equal to minus 4. So we just multiply with x, differentiate the denominator term. Differentiating this denominator term d square plus 4 with respect to d, we get 2d, and differentiation of 4 is 0. Differentiation of 4 is 0. So x over 2, 1 over d of function of x is equal to integration of function fx dx. So over here we get 1 over 2, 1 over d into cos 2x. So for this portion we just require to integrate the cos 2x with respect to x. We get pi as a x over 4 sin 2x. So the final solution will be CF portion plus the pi is x over 4 sin 2x. Now we are considering the third example, y double dash plus y is equal to cos 2x. That means d square plus d plus 1 y is equal to cos 2x. Auxiliary equation is m square plus m plus 1. For solving this auxiliary equation we get the root as a complex. For the complex root we have to compare m is equal to alpha plus minus iota beta. So the value of alpha is minus 1 by 2 and value of beta is root 3 by 2. Now for the rule of CF for complex value is e to the power alpha x c1 cos beta x plus c2 sin beta x. Now substituting the value of alpha and beta, we get CF. And for the PI, again 1 over d square plus d plus 1 cos 2x. Substituting the value of d square is equal to minus of 4 because small a is equal to 2 when we compare with sin ax or cos ax. So the value of a is 2. Replacing it, we get minus 4 plus d plus 1, that will be d minus 3. Because this is a d minus 3, 1% if it is only d, then we have to integrate cos 2x with respect to x. But this is d minus 3, so that we have to rationalize it. We just multiply it by d plus 3 from numerator and denominator. Then by multiplying it, we get denominator as a d square minus 3 and numerator is d plus 3. Now the d square is again replaced by minus 4 in denominator. We get minus 7. That will be minus 7. This is wrong. And d plus 3 is multiplied by cos 2x. D plus 3 is multiplied by cos 2x. Then this portion will be minus 1 by 7 into d into cos 2x plus 3 cos 2x. For this portion we have to differentiate only cos 2x with respect to x, that will be minus 1 by 7. Differentiation of cos is minus 2 sin 2x and this 3 cos 2x will be same. So this is the PI. Now again solution is CF plus PI portion. Now considering the fourth case, that is for PI of FD e to the power ax into function of x. That means if e to the power ax is multiplied with a function, then to solve it we required e to the power ax is solved if we are considering it on the left side of 1 over d plus a and v as a function of x. For solving this right side of the v, we will use the previous rules, like for the e to the power ax, first rule we have studied, second x to the power n, and the third rule is sin ax or cos ax. Now considering the example, like solve the differential equation of d square plus 3d plus 2y is equal to e to the power 2x into sin x. For the auxiliary equation, we get m square plus 3m plus 2 is equal to 0 and the value of m is equal to minus 2 and minus 1. Then the CF for the question will be c1 e to the power minus 2x plus c2 e to the power minus x. Now for PI 1 over d cube plus 3d plus 2 into, sorry, this is d square into e to the power ax into function of v is sin x. To solve this we have to consider that this is 2. We have to replace d with d plus 2. That means e to the power 2x is solved if we replace d with d plus 2 plus 3 d plus 2 plus 2 into sine of x. Now we get e to the power 2x 1 over d square plus 7d plus 12 sine x. As per the rule of 1 over f d square sine ax, a d square will be replaced by minus of a square. So when we replace it, e to the power 2x 1 over minus 1 plus 7d plus 12 sine x. We get the value e to the power 2x 1 over 7d plus 11 sine x. To solve this portion, we have to rationalize it. That means e to the power 2x into 7d minus 11 over 7d plus 11 into 7d minus 11 and sine x. So finally we get e to the power 2x into 7d minus 11 into sine x, and the denominator will be 49d square minus 121. To solve this value, again we replace the value of a is 1. We get e to the power 2x into 7d minus 11 sine x over 49 into minus 1 minus 121. That will be e to the power 2x into 7d minus 11 sine x upon minus 49 and minus 121 is 170. That is e to the power 2x into 7d sine x minus 11 sine x over 170. So differentiating this term, differentiation of sine, we get the pi for this portion is e to the power 2x over 170 into 7 cos x minus 11 sin x. So this is the pi, and the previously we have calculated the cf. So finally we have to find the solution, that is y is equal to cf plus pi. That means y is equal to c1 e to the power minus 2x plus c2 e to the power minus x plus e to the power 2x over 170 into 7 cos x minus 11 sin x. Now you have to solve this question. D square minus 4d plus 4y is equal to e to the power 2x into cos 2x. Solve it and submit it to your class teacher.